Hi, I'm Allie, and I'm going to be talking about search. But first, let's talk about what we're going to build in this demo. And I'm going to try to do a live situation here. So let's do it. Let's serve it and wait. Oh, this always happens. Okay, here we go. Open search, book search. I was like, what am I going to do with data? All right, let's do books. Let's just do search books. So we've got a little Hunger Games action. And there's a bunch of like stuff with Susan columns. We've got some highlighting, some filtering over here. Let's say I've had a bad night and I want to do Hunger Games. And we can see that we still have good results. There's a lot more I probably could do there in terms of like, we can have autocomplete or things like that. But that would be a lot of hours. So I was like, let's just do this. But yeah, this is what we're building. And I'm so glad the live demo worked. And I have some fuzzy match. If anyone's worked with open source search, which a lot of you have, based on the form that I sent out, then you know what fuzzy match is, and that's what kind of helps with that exact match that you have to usually do with indexes in Postgres. The TLDR is that there is a repo. You can go check it out. All of this stuff is in there. You can run it. The live demo gods are smiling upon me today. Yes, thank you, Megan. Go check it out if you'd like. I've been working on it for a while. More about me. I'm Allie. I'm a product engineer and lead designer at Bonsai. This is a real photo of me and my life right now. Just kidding. This is a real photo of me in my life right now. For all of you parents out there, it's pretty crazy. But I'm here. We're doing it. Okay, so the question is, how do you build meaningful search? And a lot of y'all responded when I asked in the forums, what is the most important thing for search? So many of you were like, the right results, relevancy. And I would say I 100% agree with you. But the first building block is a UI that supports the use case. There are many different use cases for search. You use something like Pinterest, or YouTube, it's an exploratory experience. And there are different ways to interact with your search index and build your index based on a exploratory UI versus a very specific UI that's about finding the exact thing that you're looking for, which is something like Amazon Text Us, which I don't know if anyone is here from Text Us. So the UI is the important thing, and everything builds off of there. The second thing is the ability to iterate on things. Iterate on your index, iterate on your queries to support that user experience. And the last thing is, if you have to iterate quickly, then that means you need good tools to help you iterate quickly. And we'll talk about those in a second. If you don't know what an index is, or you don't have a lot of experience with search, there's actually only a small part of you that didn't have some experience, I would encourage you to go look at storyofsearch.com. It's a comic I made many years ago, and it walks through how to create an index, what it is, some like actual structure of an index. And I did all the illustrations. It was really fun. It was quite a long time ago, but that was always a good one. Okay, back to this. So just a caveat before we start, the search world is giant, and it's getting larger every day with AI, vector search. I mean, the space is just getting so big. Within that world is full text search plus Rails. And yes, I will have those slides available and share them for y'all. And then, so like just even more caveat, let's just zoom into this area here. Like, this is what I feel like my knowledge is within this like giant search world. It's like the moon of the earth to the sun. Like that's how crazy intense this subject is. And like document retrieval, information retrieval, it's a really cool, very nerdy world. And I absolutely love it. Okay, so let's talk about the workflow that you go through in order to build the application that I showed you a second ago. First, there's a ton of setup, and you also need that UI. I didn't put that in there because that's kind of a given. But the second thing is that you have a query or a relevancy issue, you work on that query, you run the queries to test it, you identify the issue, and then you reindex. And then you keep on working on the query, and then you reindex. You work on the query and you reindex. So, okay, you're getting the idea here. Like the biggest and most important part here is you have to reindex a lot. You work on these very specific queries. So there's a lot of referencing like to documentation of like, well, how does this query work? And how do I have to form this JSON piece? And just so you know, just to get to that little like part where I have highlighting, fuzzy matching, pagination, filters with aggregations, like, you know, I got maybe like to step 8 and I've had to keep on working and keep on working and keep on working. So it's a lot of iteration. Okay, so good search and good iteration requires good tools. Let's talk about those tools. You've got your database and your data. You have the search engine itself, indexing tools, searching tools, and then front-end interpretation. Let's talk about the data first. So I just went to Goodreads and grabbed a giant CSV to index. Well, first to put it into Postgres and then put it into Elasticsearch, because that's usually like going from Postgres to Elasticsearch is usually what people or SQL deal with. And the important thing to think about is if you're doing like a practice project and you want to find some data, Kaggle is great, but I really would encourage you to look at sort of the metadata about the data set to see, you know, its score, because sometimes there are incomplete rows, or it can be really difficult to deal with certain data sets because they're not really normalized. It's a whole subject in the search retrieval world, is like finding good data sets to work with, and then also thinking about, you know, how much data do I need to test things is a whole situation as well. I feel like I'm going to give you guys all the like broad knowledge here, because you could really drill down and have like a week's worth long of conversation in every topic. But there's a really great Haystack talk called representative query sets for offline testing, and I've linked it here and I'll share the slides again. But basically the gist is with search and search technology, it's really important to work with large data sets, because that's the point of search, is that Postgres is slow after a certain point. Postgres indices are slow after a certain point. And so you need to be able to test your queries with large data sets. But like your indexing is going to take a long time, and it's going to take up a lot of space on your computer, depending on how, you know, you're doing. Like if you're doing Elasticsearch or OpenSearch locally, or if you're like deploying something in cloud, it's going to be really expensive. So it's a whole topic. That talk is a really great starting point if you're interested in that. But I just grabbed Kaggle. It's like, there's like 27,000 rows. It was like really small for a search set, and I did even smaller than that. So, okay, so let's set up the database. We've got our gem, Postgres, yay. I did want to make a note about the index search, because a lot of us do that. We do like I like searches on an index. And the thing is that you get to a certain point where that becomes non-scalable, and you really need to move your search concerns out of the read and write situation of a relational database into a specific type of data structure that is meant for search. And eventually, as things scale, the most important thing is being able to create indices, test those indices against one another, and deploy them. And so it's this whole workflow of in the production area that you really just want to separate from your schema, from your production database. We want those to be separate. So that's why when people ask me about Postgres or index search for whatever like relational database they choose, I'm like, well, it's a different thing. Relational databases are meant for long-term storage. Search databases are meant for quick iteration and throwing away and recreating pretty quickly. So, all right, I needed to get this in. I downloaded a CSV from Kaggle, and then I just created a rake task. I'm going through each row. I probably could have done this a lot, like using like bulk or some other stuff, but I was like, okay, let's just get it done. And I checked if it's new or not. So I wouldn't be writing multiple copies of something. And then, yeah, just running rake import books. That took quite a long time. So yeah, we've got our data like ready to go. So the next thing is the search engine. I chose OpenSearch, which is from Amazon, and it's a fork of Elasticsearch once their license changed from MIT or no, the Apache license to a new like weird Elastic license. So it's this whole like thing in the search world. There's some drama. It's quite fun. Um, so anyway, we're using OpenSearch today, and I work at Bonsai. We host OpenSearch. This is why I know a lot about this stuff. So I grabbed some credentials from a cluster that I'm using for testing, and I put it in my env file. You can do it in your Rails credentials file as well, but I just was doing this quick and dirty. And then I consume that URL by setting up a new OpenSearch client, which was also set up in my gem file. And then this default is the localhost 9200. That's if you have it locally. That's like the standard host for OpenSearch or Elasticsearch if you're running it on your local machine. All right, so we've got the search engine, we've got our data. Let's move on to getting that data into an index. So the important thing, and I'm going to go back a few slides here, is that I really should have added this other slide. Sorry, y'all. We have a search box, 10 blue links. This is like the standard in the search design world. You've got your top 10 results are the first ones that people see after a search. And I'm only worried about the title, the author, and the description, and then it's genre. So it's just a very few fields that I need to get things started for the driving the creation of the index. One of the things that people get stuck on is they say, okay, I have all of these fields on the book. I've got the ISBN, I've got, quotes, I've got rating, review, full text, like all these other things. And they just like shove it all into the index. But the design did not account for any of those things yet. So there's no reason to blow up your index to a giant size for things that you're not going to use in your design. So that's keeping that in mind. The design builds the index, not the other way around. I'm going to go quickly back to my other slide here. So I've got my indexing tools. I need to get data in. One of the things that we've done that I've learned over the years is how to use plain old Ruby objects, poros, to help with the process of getting data into our search engine and then getting it out. And one of the things that we use is a search model module. And it helps with some like mappings, declarations, and index features. We include this in a actual model that we want to search. So for example, in the book model, I include the search model. So we have all of those features, including some things that add it to this searchable models class. And it has a few different methods here. The index name, which we'll use later in an indexing job. Mappings, which help with the different sort of like search tools that you want to use later for querying. Index features, which are the actual fields and their values. And then the index action. The reason why I'm calling it index features will come to be more clear in a second. So in the book, I'm overriding the index features and I'm sending the things that I need for that UI. I know I want to show the author or search by the author. So I'm going to have the author. I know I want to use the description to search with to sort of see if I can like use things like PETA, Katniss, whatever the query might be to have that show up because that's not in the title, but it might be helpful. The genres, which we'll use to filter. The rating, which might be useful for scoring. And then also the title, of course. So those are the features of the search. And that is actually a very specific term in information retrieval world is like, if something is being used to search a data set, it's a feature that we use to search on. So the author is a field that is a feature that we are searching on. There's a lot of like terminology that I had to get used to in this world. Okay, back to it. So we're including this model into our book, and we're creating a rake task with the namespace of OpenSearch. And for each model, search model that I include that module with, I want to create an indexing job for that model. So it's a nice way to not have to like rewrite every single thing out, like index the books, index the, genres or whatever it may be. In that indexing job, we have a perform action, which first deletes any index that exists with that same name. So if I already have an index called books in my cluster, I want to remove it because we're re-indexing. I want to create the new indices. I'm going to push up the mappings, and then I'm going to bulk insert the records. And this batch size is just 50. I could make it bigger or smaller depending on, the needs. It also creates some nice functions to sort of think about how long that indexing job is taking. And then for the next batch size, I might increase it or decrease it depending on, how that like in-flight request is going. So yeah, we do rake, OpenSearch, reindex, and now I've got records in my index. Okay, so the indexing tools are done. Let's move on to searching tools. The searching tools, there's some basics, right? We have to have a controller action. We're calling it search and books, the index. And we're going to see if there's a params with the queue present. We're going to run this service called book searcher new with the params. And we're going to respond with the different formats available to us. In the book searcher, I'm basically rewriting things and pulling stuff out of my action so that I don't have this giant action with all these different things that I'm doing. There's a lot of stuff that I didn't include in this slide because it's actually like a much larger file, but the biggest and most important one is that I have a run method where I am creating this response variable, and I'm using the OpenSearch client to search with a body with a method called generate query, which is a giant method within the book searcher service up here that takes the params, does a lot of if block logic to figure out the best query for the user to send to OpenSearch, because that's actually the biggest part, is figuring out all the different things that you have to use with your inputs to create this big ass JSON object to send to OpenSearch. And then I'm creating a book searcher response with the response from the OpenSearch client. And the reason why I'm doing that will be more clear in a second. In this book searcher response, I take the response from the OpenSearch client and consume it. And then I have a bunch of like getter methods to parse the response. Yes, I like the budget. I've never heard that before. And just some really nice little readers so that I can consume that in the views and not have to do dig, and like go all the way into, oh, I did just invent it. Yay, that's great. And dig into all of that JSON. I hate seeing that in views, and I like things to be nice and clean when I'm accessing things. So that's why I've got this book searcher response. So it means something like this with like response, dig, hits, each do, blah, blah, blah. I have response.hits, each do, etc. And I can keep on like working down that road. Okay, the last piece is the front end interpretation, which you see a little bit here. But I've got my title, I've got a little form, and then I've got displaying the results that come back. This actually can be a lot more complicated when you get into the deep end of it. And so that's why partials are really freaking important here. I've got a search form as a partial, each hit as a partial, the filters as a partial. It's partials all the way down. And there's like way more that I could do too when this is fully built out as more of a production app. Okay, that is a lot. And I feel like most of the thing that I was doing is just creating this repo as a resource. And I'm going to continue to work on it. And it's open source. Please use it. Please ask me questions on it if you'd like. Fork it. Tell me, you're so silly. Why would you do a book searcher response? You should do this instead. I don't know, whatever. And I will say as a final caveat, like, all the things in here, the different search tools, the rate tasks, the way that I'm doing the indexing job with a search model, whatever it may be. These are best practices, using the poros, having something to handle your query response. However, there's also like tech debt, time constraints, multiple rewrites, weird things going on with your team. And there's the thing that ends up shipping. And that's the most important part. What are we actually shipping? And like, what are we getting in front of users? So I'd like to just offer that as a final close. Questions?